Hi, good morning to everyone. Myself, A. Ramanand. Okay, in previous session, we discussed about torsional equation and power transmitted by the shaft and their units. Okay, in this session, we will discuss the problems regarding the calculation of power, torque, and diameter of the shaft and angle of rotation. Okay, coming to the first problem, calculate the maximum intensity of the shear stress induced and angle of twist produced in degrees. Okay, in solid shaft of diameter 100 mm and 10 meters long. Okay, next, transmitting 120 kilowatts at 150 rpm. Take G is equals to 82 kilonewton per meter square. Here problem given that a shaft with diameter 100 mm and length is 10 meters long and it is transmitting a power of 120 kilowatts at speed 150 rpm. Okay, first of all, before solving the problem, we need to note down given data. That is, diameter of the shaft is 100 mm diameter. Next, length is equals to 10 meters. The value of length, we need to convert the units because here the G value, that is modulus of rigidity, given in terms of Newton per mm square. So that in the every property or every parameter, we need to convert into newtons and millimeters. Okay, so that length of the shaft is 10 meters, so that convert into mm, so that 10 into 10 cube mm. Next, transmitting 120 kilowatts, that is 120 into 10 cube watt. Next, speed is 150. Next, modulus of rigidity is 82 kilonewton per meter square. First of all, and after completion of required given data, we need to identify required data. What we have to find out? Okay, here we need to calculate the maximum intensity of shear stress, that is Q suffix x. It is the maximum amount of shear stress, where the maximum shear stress will develop means at the surface of the shaft, that is maximum radius from the center of the shaft, that is capital R. Okay, next, angle of twist, that is theta in degrees. Okay, based on the given data, the given power, torque. Okay, based on that given data, first we can calculate the torque developed by the shaft, that is by using the equation power P is equals to 2 pi nt by 60. In this equation, we know that P value and speed value. By substituting the power and speed in this equation, we will get the value of torque, that is 7.6394 into 10 power 6 Newton millimeter. Here power we calculated in, that is power equals to 120 kilowatts, 120 into 10 cube. Here watt means Newton meter per second, so that Newton meter per second, so that converted into Newton meter per second into Newton millimeter per second, so that 1 meter equals to 10 cube, so that finally the power value is 120 into 10 power 6. By substituting all the values in the above equation, we will get the final value of torque, that is 7.6394 into 10 power 6 Newton millimeter. Okay, next, from this equation, by substituting the value of torque in torsional equation, we know that torsional equation is T by J equals to Q by R equals to G theta by L. In that torsional equation, consider first two terms, that is T by J equals to Q by R. Here we need to calculate the maximum shear stress, so that maximum shear stress will develop at the maximum radius, so that we need to take the radius value is maximum, so that T by J is equals to Qs by R. Okay, in that equation we know that T value and R value. R is nothing but half of the diameter, that is R equals to D by 2, and by substituting the J value we will get the shear stress in this equation. Okay, J equals to pi by 32 D power 4, pi by 32 into D is 100 power 4. By substituting these values in this equation we will get the value of QS, that is 38.91 Newton per millimeter square. Okay, next coming to angle of twist, theta is equals to TL by GJ. Okay, in this equation we know that T value, next L value, G value and J value. By substituting all these values in this equation we get the value of angle of twist, that is 94.895 into 10 power minus 3 radians. But they required angle of twist in degrees. To convert radians into degrees, we need to multiply the 180 by pi. By multiplying the 180 by pi, the radians will convert into degrees, so that the final value of angle of twist, that is 5.437 degrees. Okay, it is the angle of twist developed in the shaft. Okay. The sound was better.